Hey guys, it's Miss C. So we're going to start our first sync lesson. What we're going to be doing is we're going to review some trig graphs because I wasn't with you to teach them. And then we're going to start looking at some trig word problems. You have 3 assignments this week. Your first assignment is going to be related directly to what we do in this lesson. And it's due tonight at 11:59 on Canvas. So you're going to go into your Canvas, into your assignments or quizzes, it's in both spots, or go into our distance learning tab, it's going to be linked. And you're just going to transfer over your multiple choice answers from the homework that's on the back of the worksheet. And then you're going to have 2 other homework assignments that are going to be due on Canvas as well, due Wednesday and due Friday. Those are going to be more of a review of trig graphs and just a review of concepts learned earlier in the year. I added a little positive quote because I miss you guys, and it's so important that we all stay positive and happy and healthy during this time of uncertainty. And my last piece before we start is to follow along and take notes on the worksheet. You can find the worksheet and the materials and the keys for this lesson under our distance learning tab. So on our Canvas homepage, hit the big red link that says distance learning and it will take you right to our assignment page. All right, so let's get started. So the first thing I want to go over is how to write an equation of a trig function using a graph. So we were all just logged on to our virtual classroom. We went over some important vocab terms regarding trig graphs, and then we went over in the general form of an equation and then the different transformations that can happen. So now that we went over that together, I want to show you just how to write the equation using a graph. So when we're writing the equation, we need 4 different values. We need A, B, C, and D. A is our amplitude, B is our frequency. Frequency is how many cycles occur between 0 and 2 pi. C is something called a phase shift. We haven't really done much with the phase shift. We're going to look at a phase shift in the next example, so don't worry about that. And D is our vertical shift or our midline, so how much the graph has moved up or down from the y equals 0 line. So when we're trying to figure out how to write this equation, our first step is to figure out what this trig function is. So it could either be sine or cosine right now. So looking at this, we're going to automatically know that it's cosine because it starts at a number. If it was sine, it would be starting at 0. So since it starts at a number like 6, we can automatically say that this is a cosine graph. The next value that we're going to want to find is our amplitude. So we want to find A, which is our amplitude. Amplitude is how high or how low the graph goes from the midline. So looking at this graph that we're given, we can kind of assume that the midline, or where the graph gets cut in half, is at y equals 4. And then we see that our max occurs at 6 and our minimum occurs at 2. So our amplitude, or the distance it goes from the midline to the max, or the distance it goes from the midline to the min, has to be 2. The next value that we're going to want to find is our frequency, so our B value. In order to figure out what our frequency is, we have to know what one complete cosine graph looks like. So the generic or basic cosine graph follows this shape. Starts up, goes down, comes back, and it looks like that. This is something we saw early on in one of the other lessons. So it starts at a number, goes down, comes up. So that's one full cycle of a cosine graph. Let's see how many we have in this graph. So frequency is between 0 and 2 pi. So let's see. We go down and we come up. That's one full cycle. Then we go down and come up. That's another full cycle. So from 0 to 2 pi, we have 2 full cycles of cosine. So that means our frequency is 2. The next value that we're going to want to find is our C value, or our phase shift. So a phase shift is the horizontal shift, meaning we have these critical values of pi over 2, pi, 3 pi over 2, and 2 pi. Those are the quadrantal angles. So that's 90, 180, 270, 360. If we had a phase shift or a horizontal shift, our critical values would change. They would shift over by a certain amount. So since we have pi over 2, pi, 3 pi over 2, and 2 pi, we know that there is no phase shift because they aren't changing. They're still the quadrantal angles. So that C value isn't going to be important to us right now. And the last value that we are going to find is our D value, which is our midline or our vertical shift. So midline and vertical shift are pretty synonymous. The amount that you shift up or down becomes your midline. So our vertical shift, obviously we know that our cosine graphs, the midline for a generic one is y equals 0. But here it's very clear that our midline shifted up 4 units. So our vertical shift was up 4. So that means it went plus 4. And our midline would be y equals 4. So looking back at our generic form of a trig graph, we have A is our amplitude. We have what our trig function is. It's a cosine graph. That's what we figured out first. We have our frequency B. There's 2 full cycles of this graph. We don't have a phase shift, so C is just 0. And we have D, our vertical shift. We know it's going up. So we have enough information to figure out the equation of this graph. So y equals our amplitude of 2 times cosine. My frequency is 2 times x. I'm just going to put plus or minus 0 here because C is just 0. There is no phase shift. And then plus or minus, nope, it's just plus 4. So our equation is y equals 2 cosine of 2x. I'm going to put parentheses around it, plus 4. And that's it. So now we're going to sketch the graph of the following equation. So I just took a second and wrote down all the important critical points. Obviously having the amplitude of the graph is important, frequency is important, and these are all things you can just pull right from the given equation. Having the phase shift is important, which I said that we were going to talk about that before, and now we're going to talk about it now. And then also the vertical. Now, obviously these are all values that you can pull right from the equation. And then there's other values that are important that we can use the values from the equation to find, like the period, the midline, the max value, and the minimum value. These are all really important when we're trying to sketch a graph. But I just want to pull up and, so I see right away that there is a negative in front of the equation, and we know from any transformation that a negative in front of an equation just means that we're reflecting over the x-axis. So I wanted just to show you an example of one where there is a negative in front and we are reflecting it. So let's pull the amplitude. The amplitude is going to be our A value, which is right next to that negative, which is just 3. So that means the distance from the midline to the max and the distance from the midline to the min is 3. Just a little mistake that I see commonly is people include the negative with the amplitude. The negative is just telling us if we flip over the x-axis or not. Another way to remember that you shouldn't be pulling the negative is amplitude's a distance, so it's a distance from the midline to the max or the distance from the midline to the min, and distance is never negative, so that's just a way that you can remember not to pull the negative. The next value that we're going to pull from our equation is the frequency. The frequency is this B value right in front of where the phase shift happens. Obviously, there's no B value, but there's an imaginary 1 there, so our frequency is 1, meaning that there's one full sine curve from 0 to 2 pi. The next value that we can get is our period. So period we find with an equation, and it's 2 pi over b. So our period is 2 pi over our frequency of 1. So our period's 2 pi. So that means there's one full sine curve that takes 2 pi long. So it's the time it takes for one full curve to occur, and then the time is 2 pi. I'm going to skip phase shift right now. We're going to come back to that. That's just a little bit difficult to understand. Let's just take care of the other easier values. Our vertical shift is this d value, so this plus 3. So that means it is going up 3. So we know that for any generic sine or cosine function, the midline is always y equals 0. However, if we have this transformation that brings it up or down, the midline turns into whatever that transformation is. So our vertical shift is up 3. So now that means our midline isn't y equals 0, it means it's y equals 3. So after we find the vertical shift and the midline, we can use that to find our max value and our minimum value. So our max value is our vertical shift, d, plus whatever our amplitude is. And our minimum value is our vertical shift, d, minus our amplitude. So our vertical shift is 3, plus our amplitude of 3. So that means the max value that our graph reaches, or like the peak occurs at, is 6. And our minimum value is 3 minus 3, which is 0. So our minimum value, or the valley of our graph, happens at 0. Okay, so that's all the information that we can pull from our equation. And that's a lot of information. You could probably make a pretty good sketch of what the graph looks like. However, we need to take into consideration this phase shift. And the reason that we know there's a phase shift is because we have an x plus something, an x plus c, and c is our phase shift. So we know that whenever we're doing transformations and we're shifting something on the x-axis, we normally associate the positive direction, so plus 2, we associate that with going to the right. However, when we're doing shifts with graphs on the x-axis, the positive direction is actually the left direction. So what this x plus pi is telling us is we're moving our critical values to the left pi. Now, since we're moving to the left pi, it says x plus pi, but that plus is just telling us to move to the left. So that means we're taking pi over 2, or 0, and we're moving it to the left pi. We're taking pi over 2, and we're moving it to the left pi. So if we're moving to the left, we actually have to subtract pi. So the same would be true as if we were moving to the right. It would say x minus pi, but since we're moving to the right, we actually have to increase it by pi. So that's just a little bit of something that is a little counterintuitive and just requires a little bit of extra thought. So all phase shift means is you're taking your critical values of 0, pi over 2, pi, 3 pi over 2, and 2 pi, those quadrantal angles, and we're just shifting it over by some amount. In this case, we're shifting it by pi. Okay, so let's start with our first point on a sine graph. We know that on a sine graph, our graph starts at 0, 0, or the origin. Now we have this phase shift, so we're moving our x values, or our critical values, over to the left pi. So we have to subtract pi. So we're going to take our x value of 0, and we're going to subtract pi. So now this point turns into negative pi, because 0 minus pi is just negative pi, comma 0. So that's our first point shifted. Let's shift our next point. So our next critical value is pi over 2. And pi over 2 occurs at 1. If you notice that none of our y values are changing, we're just shifting our x values. So we're taking pi over 2, and we're shifting it over pi. So we're doing pi over 2 minus pi. Now, pi is actually over 1, and we can't combine those yet. We need to get a like denominator. So it's actually pi over 2 minus 2 pi over 2. And pi over 2 is now happening at negative pi over 2. I'm actually going to get rid of these y values because they might confuse you. Because it's not actually 0 and 1 because we have a vertical shift. So right now, all that's important is we're just finding out these x values. We'll take care of the y values later. So I'm just going to erase those. So all that's important right now is we're seeing that our 0 x value is now negative pi, so we shifted over negative pi. Our pi over 2 x value is now negative pi over 2. Our next critical value is just pi. So we're shifting it to the left pi times. So our pi x value turns into 0. And I want you to complete the rest of them. So I want you to do the critical value of 3 pi over 2 and then do the critical value of 2 pi. Okay, so we take the x value, our original critical value of 3 pi over 2, and we shift it over to the left pi. So we do 3 pi over 2 minus pi, and we get 3 pi over 2 minus 2 pi over 2 because you have to get a like denominator, and we see that 3 pi over 2, that critical value turns into pi over 2. So all we're doing is just taking our critical values and we're kind of like moving them over. So nothing's changing, it's just where our graph is going to hit changes. And then we do our last critical value, which is 2 pi. 2 pi minus pi is just pi. So instead of labeling our x-axis 0, pi over 2, pi, 3 pi over 2, 2 pi, we're going to label them with these. So 0 now turns into negative pi, so let's just do that now. We'll label our x-axis. So let's draw an x-axis, and I'm going to label negative pi over here. Pi over 2 turned into negative pi over 2. Pi shifted to 0. I'm just going to draw that line, the origin, just because that's where it is. 3 pi over 2 turned into pi over 2. And 2 pi turned into pi. So now instead of our graph going from 0 to 2 pi, we shifted it over pi units, and it goes from negative pi to positive pi. So let's start graphing this. Let's place our midline. So our midline is y equals 3. So obviously this x-axis is y equals 0. So I'm going to place my midline at y equals 3. And let's see, our minimum value occurs at y equals 0, and our max value occurs at 6. So let's draw that in. All right. So at 0, or at our new 0 point, which is negative pi because we just shifted it, we know that sine is 0. So we're going to place a dot on the midline because that's our new x-axis. Then at pi over 2, or negative pi over 2 because we shifted it, it goes to our max value. Then at pi, or at 0, because we shifted, it goes to our 0, our midline again. And then at 3 pi over 2, or in this case pi over 2, it goes all the way down to our minimum value, and then we end at our midline again. And then we trace it. So there's our sine graph. Let's just double check. The frequency between negative pi and pi should be 1. Well, that's one full sine curve. And our amplitude should be 3. So from our midline up should be a distance of 3. Well, from 3 to 6, it's 3. And from 3 to 0, it's 3. So that's what a sketch of that would look like with a phase shift. Okay, so we've been learning some basic trig graph vocab, how to graph some trig graphs, how to write the equation. So now we're going to start applying them. So that means we're going to do them in real world scenarios. So that means word problems. Before we start these word problems, they are a little tricky, so don't get discouraged. But we're going to practice them a lot. I just want to go through what different keywords mean and introduce some formulas that might help you. So the first thing that they might ask you to do is find A. So A is obviously our amplitude. And in the word problem, they might say the longest or the shortest. Those are keywords. Those are saying the longest is our max value and our shortest is our min value. So an example of a word problem would be somebody's heart rate. Somebody's heart rate follows a sine curve. So they might say that their highest heart rate was 120 and their lowest heart rate was 70. So that's just a key word saying, well, their max value is 120 and our min value is 70. Another equation that might help you is the amplitude equation. So the amplitude is just the max value minus the min value over 2. That might be helpful. The next thing that they might have you find or look at is our frequency. So frequency is how many complete curves by 2 pi, but they might not give you the frequency right outward. They might say, well, it takes this long for one cycle. So if they're telling you how long for one cycle, that means they're giving you the period, and then you have to use the period to find the frequency. And the last thing they might have you look at is a vertical shift or a midline. Midline is the middle of the max and min values. And an equation for the midline, so if they give you the max and min values, you can find the midline. It's just max plus min over 2. It's the average of the max and min values. It's the middle of the max and min values, which makes sense. So let's just jump right into these and start using these formulas. The temperature in an office is controlled by an electronic thermostat. The temperatures vary according to the sinusoidal function. Sinusoidal just means it follows the trend of a sine graph. Y equals 19 plus 6 sine pi over 12, x minus 11, where y is the temperature in degrees Celsius and x is the time in hours. So before we start answering these questions, I just want to clear some things up. This is a general form of a trig equation. However, the only difference is our vertical shift is in the front. I'm just going to rewrite it so it's in the back, so it looks just like the ones we've been working with. Okay, so that looks more like the ones we've been working with. The second thing that we need to take care of is, so when we're doing trig graphs, I said that your calculator should always be in radian mode. That's still true. However, in this particular case, they're giving you that the temperature is degrees Celsius. Now, I see a problem. We have a radian in here. So before we can use this equation, because we're working in degrees, we have to change our radian to degrees. Now, whenever you're graphing with trig, you have to have your calculator in radians. But if you're doing like calculations or anything that's not graphing, honestly, I would say have it in degrees. So let's just change pi over 12 into degrees because they're asking you for degrees Celsius. If they weren't asking you for degrees Celsius, you wouldn't have to do this. But since they're asking for specifically degrees, you have to change radians to degrees. So pi over 12 to change it to degrees is 180 over pi. So pi over 12 is 15 degrees. So I'm just going to rewrite our equation. Y equals 6 sine of, instead of pi over 12, I changed it to degrees. 15 x minus 11 plus 19. All right, so now we're good to go. So the first question is, what is the temperature of the office at 9 a.m. when employees come to work? So x in our word problem is the time in hours past midnight. So they want to know what the temperature is after 9 hours. So all we're going to do is just use our equation. Y equals 6 sine of 15, 9 minus 11, plus 19. They're giving us the amount of hours since midnight, and y, or our output, is our temperature. So we want to know the temperature after 9 hours. So all you're going to do is start plugging and chugging. So 6 sine 15 times negative 2 plus 19. Y equals 6 sine. So we get y equals 6 sine of negative 30 plus 19. So you can just plug this into your calculator, but it's so important that it's not in radians and we changed it to degrees. You should only be in radians when we're doing graphing. We're not graphing anything. We're just applying some ideas of graphs, so you should be in degrees. So the sine of negative 30 is just negative 1/2. So 6 times negative 0.5. So all I did was just put the sine of negative 30 into my calculator, plus 19. So the temperature after 9 hours is 16 degrees Celsius. So after 9 hours, temp is 16 degrees Celsius. part B, they're asking what the minimum and maximum temperatures are in the office. And we looked at that little chart before. And when they're asking for the longest or the highest or the max, they're actually asking for the max value. And when they're asking for the shortest, the smallest, minimum, they're asking for the minimum value. So our max and minimum values we just find with the formula. So our max value of this sine graph is whatever our vertical shift is plus our amplitude. And our min value, or the minimum value of this sine graph, is whatever our vertical shift is minus our amplitude. So let's just look for our amplitude and our vertical shift. These are two values that I can pull from my equation. So that's the reason why I switched the order in the beginning, so we wouldn't get confused. Our amplitude is the A value, which is 6. So the distance from the midline to the max, or the distance from the midline to the min, is 6. And our vertical shift is up 19. So our max value would be 19 plus 6, and our min value would be 19 minus 6. So our max value is 19 plus 6, which is 25 degrees Celsius, and our min value is 19 minus 6, which is 13 degrees Celsius. So the hottest it gets in the office over a course of a day is 25 degrees Celsius, and the coldest it gets in this office over the course of a day is 13 degrees Celsius. Number of hours of daylight measured in 1 year in Ellenville can be modeled by a sinusoidal function. During 2006, not a leap year, the longest day occurred on June 21st with 15.7 hours of daylight. The shortest day of the year occurred on December 21st with 8.3 hours of daylight. Write a sinusoidal equation to model the hours of daylight. So all I did was write down the general equation of a trig function. So y equals a times sine bx plus or minus c plus d. And we need to use this information given to us to fill in those missing values. So the first is our amplitude. Don't outwardly say our max value or min value or the amplitude is, but they do give us the longest day and the shortest day. Now, if you remember back to that little chart, longest is code for max value. Shortest is code for min value. So they're really telling us the max or the peak of this sine graph is 15.7. And they're telling you that the min or the valley of this sine graph is 8.3. And we have enough information to find the amplitude. We have a formula. Amplitude is max minus min over 2. So it's 15.7 minus 8.3 over 2. Got to put the absolute value sign over it because amplitude can't be negative. And we get our amplitude is 3.7. So we have our A value. Cool, we can move on. Let's talk about finding our B value. So this graph is measuring the total number of hours of daylight measured in 1 year in Ellenville. So that means one complete cycle of a sine graph happens over the course of 1 year. 1 year is 365 days. So one full cycle occurs over 365 days. So are they giving us our B value or are they giving the period? Well, they're giving us the period because they're telling us one whole cycle occurs over 365 days. So since they're giving us our period, we can use that to find the B value because we know that period equals 2 pi over B. So 2 pi over B equals 365 days. And then we're just going to cross multiply and solve for B. So we're just going to cross multiply. So B times 365, 1 times 2 pi. So we get 2 pi equals 365b. Divide both sides by 365, and we get that the frequency, or the time it takes, the amount of sine graph curves that fit in between 0 and 2 pi is 2 pi over 365. All right, so we have our A value, we have our frequency, and the last thing we need to get is our vertical shift, or our midline. So, to find the vertical shift, we need to know what our max value is and what our min value is, because we have a formula. Vertical shift is max plus min over 2. It's the average of our max value and our minimum value. It's the middle of our max value and our minimum value. So 15.7 plus 8.3 over 2. And we get that our vertical shift is 12. So our D value is 12. Now we don't have any phase shifts here, so we don't need to worry about our C value. We have all the information we need, so we can finally put it all together and write our equation. So y equals, A is our amplitude, 3.7, sine, B is 2 pi over 365, times x, plus or minus c, we don't have a phase shift, so we don't need to include it, plus 12. So that is the equation that models this situation. Above the ground can be modeled using the equation h equals 1.75 cosine pi t plus 2.25, where h represents the height of the yo-yo in feet above the ground, and t represents time in seconds the yo-yo was first dropped. So I want you guys to try this one by yourselves. I'm going to go through it, but I want you to pause the video, attempt part A and B by yourself, and see what happens. So A is determine the max and minimum heights that the yo-yo reaches above the ground. Obviously, you're going to be finding the max and minimum values. And part B is how much time does it take for the yo-yo to return back to its max height for the first time. AKA, this is asking how long does it take for one full cycle. So, in reality, they're asking you to actually just find the period. So what I want you guys to do is pause the video and try to figure these two out. Okay, so you should have paused the video and tried these questions by yourself. To find the max and minimum heights the yo-yo reaches, they're really just asking for the max and minimum values of our cosine graph. So our max value is D plus A, so our vertical shift plus our amplitude. Those are just values you pull right out of the given equation. So it's 2.25 plus 1.75. So our max height is 4 feet, and our min height is D minus A, which is 2.25 minus 1.75, which is 0.5. So our minimum height is 0.5 feet. And how long does it take for the yo-yo to return to the max height for the first time? So they're basically asking you how long does it take for the yo-yo to go through one full cosine cycle. That is just our period. Period is 2 pi over b. B is our frequency, which is just our b value in our equation. Our frequency is pi. So period is 2 pi over pi. So the amount of time it takes for the yo-yo to go through one full cycle is 2 seconds. Okay, so that is it for the lesson. What you guys are going to do now is flip over your paper and complete the homework assignment. It's 2 questions, multiple choice. Complete those 2 questions and transfer your answers onto Canvas before midnight tonight. And then you have 2 more assignments posted on Canvas that you are going to complete for Wednesday and then for Friday. I hope you guys stay safe, stay happy, stay positive, and I will see you very soon. Bye.